Assalamualaikum warahmatullahi wabarakatuh and hello to everyone. So first of all, I would like to introduce myself and my team members. So my name is Muhammad Alif Aiman bin Ramli and my team members is Muhammad Ashraf bin Muhammad Zulkifli, Mahe Abdul Aziz Abdul Maj Ahmed Ali, and lastly Toslima Ferdaus. So this is our first group assignment and we need to answer the question given by our lecturers. So the question for our group is question 9 and this is the question. So I will proceed with the answer for A. So for question A, we need to redraw and label the process flow diagram given in figure 1 completely. Before I draw this process flow diagram, I let N equal to sodium carbonate, S to crystal, solid, and salt to solution in order to make to draw this process flow diagram easier. So from the question, we know the basis given is 10,000 lbm per hour of 13% sodium carbonate solution combined with recycled stream fed to evaporate. So from the evaporator, the water is vaporized and the concentrated stream leaving the evaporator is fed into a crystallizer. Then it is cooled to obtain the crystal solid from the solution of sodium carbonate. In this stream, the solution is still remain, but because not all the solution can get to be converted into the crystal. So then it fed into the filter and the outlet for filter is the same, which are crystal and solution. So for this stream, it is given that 3.5 lbn crystal per lbn solution, which means 3.5 lbn crystal is 1 lbn solution. So for the composition in the solution is given that 17.7 lbn net sodium carbonate equal to 100 lbm of solution, which means is for the composition of sodium carbonate is 0.177 lbm sodium carbonate per lbm solution, and this composition is the same in the composition for the recycled stream. So lastly, for the boundary, we can get 5 boundary from this process system. A is for the overall boundary and B is for mixing boundary, which is sodium carbonate solution mixed with recycled stream, and the boundary C is evaporator, and boundary D is crystallizer, and lastly for boundary E is filter. So for the boundary, for the line of boundary, we need to do with dash line, and because of I can't find the dash line in PowerPoint, I just do like this.
Okay, now we proceed to the question B. Question B asks to calculate the mass flow rate of crystal IBM per hour produced from the filter, and then the basic is 10,000 IBM per hour of 30% sodium carbonate solution combined with recycled stream feed to evaporate. And from boundary A, we can see that we have 2 output and 1 input. And after that, we do the DOF analysis, and the unknown we have 3, M1, MC, and M5. And the equation we have 2 mass balance, which is sodium carbonate and H2O, and the given ratio is 1, is ratio of M5 over MC equal to 3.5. Okay, based on the DOF analysis, we do the calculation for a ratio given and we get M5 equal to 3.5 MC, and we label it as equation number 1. And then we continue to the sodium carbonate solution and we get the equation, then we label it as equation number 2. And then from that, we substitute equation number 1 into equation number 2 and we get the value of MC. Then after that, after we get the value of MC, and then we substitute in equation number 1 and we get the value of M5.
So for question C, based on the overall boundary is boundary A, So we did the H2O balance, and the H2O balance is 10,000 multiplied by 0.7 equals to M1 plus M6 multiplied by 0.823. M1 equals to 7,000 minus 815.88 multiplied by 0.523. M1 equals to 6,328.53 per mass H2O per hour. So for question D, the mixture boundary is from boundary B, and we did the DF analysis and we drew the diagram. Because, of course, because of it's a mixer, so we have two inputs and one output. So the given is 40 over 100 multiplied by m multiplied by 1 minus x equals to m1. So m equals to m multiplied by 1 minus x equals to m1 multiplied by 100 over 40. So m multiplied by 1 negative x equals to 6,328.53 multiplied by 100 over 40. So the answer is 15,821.33 bar mass H2O per hour. So the H2O balance is 10,000 multiplied by 0.7 plus MR multiplied by 0.23 equals M multiplied by 1 negative X. So 7,000 plus 0.823 MR equals, so the MR equals to 15,821.33. So the ratio will be the MR equals to 10,718.5 power mass so per hour. So the ratio would be the MR number is, which is 10,718.5 over 10,000. So it will come up to 1.07185.
Okay, the question is asked about, is it possible to replace the evaporator with the dryer, and give your reason. I think it is not possible because drying is a process in which a wet solid is heated or contacted with a hot gas stream, causing some or all of the liquid wetting to solid to evaporate, and the vapor and the gas evaporate into emerge as one outlet stream, and the solid remaining residual liquid emerge as a second outlet stream. And on the other hand, evaporation is a process in which a pure liquid mixture or solvent in a solution is vaporized. As the dryer is used for drying operation, in which moisture is removed from the solid particle, and the system use the sodium carbonate solution, it just can be go through evaporation operation, in which moisture removed from liquid phase, and evaporation is good to remove a large amount of water from solution. Now we proceed to the question F. Question F asks about, one of the project engineer from sodium carbonate crystal company suggested that the recycle stream should be removed from the exciting process for a new proposed plant. And why the project engineer suggested the idea? Do you agree? And I think the project engineer suggested that idea because it costs a lot to pay for the separation and recycle equipment. I do not agree with the suggestion because there are so many benefits for using recycle stream in the process. In the train, a slurry of solid particles suspended in a liquid passes through a porous medium. Most of the liquid passes through the medium to form the filtrate, and the solid and some entrained liquid are retained on the filter to form the filter cake. And recycle stream also use a recovery of catalyst, dilution of process stream, control of a process variable, and circulation of working feed. Thank you.